Hi, Michael.
Hello, Jan. How do you do?
Everything fine? Back in Star Wars.
Yes, indeed. Yep. Yeah. I'm really
It's getting
enjoying the mural.
it's getting used. It's nice what your daughter did.
Hmm. Yeah, I still do need to rearrange the furniture to make best use of it. Um, I mean,
Mm,
it is kind of nice that there's a nice little gap here. You can see the droids, but um, yeah,
mm.
I think we can do something better back here.
I think it perhaps turn turn the camera a little bit that you are in front of the door,
Hmm.
and then on the right you have the background.
Yeah. Hmm. Yeah. Unfortunately, that would put the camera right here at the window. There's a huge window right there.
Ah, yeah.
Yeah. Hmm. Yeah. Might be able to do something like that though. Yeah.
So that you see more of the background because the background is you cover the background now
Yeah.
for yeah. Um,
That is
well,
true.
it will be some testing, some
Hmm.
experimenting. Good, Michael. The syntax.
Yes. Yes.
I've been playing. How can I? Because now I'm not working in a virtual machine with Visual Studio. Uh, Wait, if I could just share my.
Hmm.
Let's see, applications. Strange. What is which screen is what here? Um, that's strange. Um, see, Ref Microsoft Docs. No, it's not that one. Uh, String unit. No. Ah, I can still scroll. Okay. I'm always surprised by Discord. Uh, I think it I think it should be that. Yeah, that's it. How can I see?
Okay.
You see the screen?
Yes, I do.
Is it readable like this?
It is a bit small. Um, you could
Um,
probably just
wait,
hit
wait.
Control Plus
Otherwise, I
to
make it
increase the
just.
font, and then
I just
okay.
scale it to a quarter a quarter of the screen.
Oh, okay. Yeah, there you go.
Is it better like this?
Yes. Yeah, it is.
Right, but I'm gonna shift it to another port that's closer to me. Yeah. No, this is not working. No, no, moment. Like this. It is visible like this. Then
Yes.
okay. So it's. I didn't got very far, but at least I got the descriptive string out of the compiler,
Hmm.
and then I said, okay, now let's look up the syntax, and it was not the first part of the meeting that was missing. It was the last part of the meeting that was missing.
Right. Yeah. Yeah. I was having
Um,
trouble with the recording.
yeah, so we missed the part with the description. Um, so actually here we have three objects. Uh, Now it's so small here. I left everything like it was.
Hmm.
So instead of model, I made a model dash DWS.
Hmm.
Just three objects in it: a supplier, a user, and a worker. So the user and the supplier are top-level objects. The worker is a successor of both.
Okay.
Yeah. Um, so that means if we simply say here, I can specify a worker starting from a supplier. Yeah, the specification, this is running fine.
Mm-hmm.
The compiler gets it, because if I put a breakpoint here, he will give me the string. Yeah, so
Yeah.
if we just, where's my test here? Was it this one? If I go debug this test, so it should stop there. Okay, so go one step further. Why is he giving nothing here? Yeah, he's giving it anyway.
Yeah, that is strange, because yeah, it should have made it past that line, and
Anyway,
you can see it there.
what is funny, these green squiggles that you saw last time
Mm-hmm.
on your side, I don't have them.
Oh, okay. Yeah, it must have been just a strange timing issue.
Yeah. Don't know, but at least that's something that is going well on my side. Not everything goes wrong. Here, descriptive string. Where's my @watch gone? Okay.
Yeah, now it shows
Here
up.
it is.
Mm-hmm.
Yeah, it shows up, so that's fine. But then we have all these carriage returns in it.
Mm-hmm.
What I did, I actually copied it in, removed the carriage returns, made them real carriage returns.
Mm-hmm.
But then this syntax, because actually you started from the syntax diagrams in the inverse query chapter.
Right, yes.
Yeah, but these are not inverse queries. These are the forward queries.
Correct, yes. Yeah. So the syntax is going to have to expand a little bit to support reverse queries. But yeah, this is kind of a starting point of that work. Yeah, in order to support reverse queries, we'll need to do things like identify the changed or the facts added and facts removed and the affected set. So those are concepts that still need to be added to the syntax.
Yeah, but because of in JavaScript, the inverse queries are not implemented.
Right. Yeah. So the big issue that I discovered when working on the chapter for the book is that the implementation in JavaScript, it does compute multiple inverses for a single query. In the case of the JavaScript version, it's always a single line from one starting fact to one set of ending facts. It doesn't branch, so you can't do projections. And so it does find multiple inverses, and then for each one, it finds the affected set for and facts added and facts removed for each one. The problem is that it doesn't have a way of putting a point within a pipeline and working in two directions. So you might remember from the book, I've got a visual syntax of showing that there's a dot coming down from one pipeline that then feeds into another pipeline that goes in two different directions. And that's so that you can start from there and compute the facts added and the affected set in both directions from that point. Mm-hmm. And that produces a smaller set of changes. If you just take the approach that's in Janaga.js, it doesn't pre-compute part of it and then start from there. Instead, it starts both of them from the beginning. So you get a Cartesian product of all of the the results. So the JavaScript version is inefficient in that way. So that's the primary difference. It doesn't support projections, inefficient inverses, and then there's also some scenarios where it's just incorrect. It doesn't include all of the the correct results. So so yeah, there's basically one of the very next steps on this is to do a correct implementation of the query inversion algorithm, and then once that's all working, I'll find a way to backport that to the JavaScript version.
But so this descriptive string, what is exactly the meaning of it? Because we start from a supplier of type DWS.supplier.
Mm-hmm.
Is that a type that we have here?
Yes, exactly. Yeah, so that's the type that you've declared in your attribute for that class or that record. Mm-hmm. And then
and then we look for workers of type DWS worker.
Yeah, and the way that we do that is that we start from the supplier, and then we take the successor in the role supplier, and we look for things of type DWS worker. So that is just a...
The S means successor.
Yes.
And then in the role supplier. Okay.
Right. And that role is what you see on line 17, where worker.supplier. That supplier right there is the role.
Yeah.
It's the name of the field that points to the predecessor.
Mm-hmm. Okay. So that was the successor. No. So we have a supplier, and then we look for workers which are no. What is the meaning of this equal?
Yeah, so the
equal sign.
Yeah, the equal sign isn't a comparison equal. That's a definition equal. So if I could, I would have a triple, a 3-line equal sign there, defined as.
Yeah.
So so what's happening is what you see in the book is a graph of all different steps put together, and so you've got a huge branching structure that could happen there. In order to convert that into text, the way that I chose to do that is to give parts of the graph names, and then you could say this part of the graph starts from there and continues forward. So the first part of the graph that gets a name is supplier. It's the input, and then the next part that gets a name is worker.
Here.
Right, exactly. So so worker is really just a small segment of the graph that takes that supplier successor step. So it's saying, okay, starting from supplier, so that's what tells it to take the input and hook it onto that node. Then follow the supplier successor relationship. Now you've got a set of all things, all facts that point to this one as their supplier, and then further refine that list based on the type. So now only the DWS worker facts, and so now that is a graph that just has the start and the successor step with those constraints in it, and then that last worker on line 26 is the projection. It's saying, what do you want to get out of this this graph? So I just want the output of the part of the graph that's labeled worker. So this one actually creates a very linear two-node graph of just starting at DWS supplier, and then take the successor, role supplier, type DWS worker. So it's a verbose way of describing a very simple graph, but that verbosity means that we can describe more complex graphs too.
Yeah, my supplier was the top level. So take a supplier, then goes to the successors in the role supplier,
Mm-hmm.
and all these successors of type worker.
Right.
And
exactly.
so if I could have other successors as well. For example, in my case, I had a successor client.
Mm-hmm.
A client is a successor of a supplier as well. So that's why I mention here, no, give me only the workers.
Right. Exactly.
Okay. And so actually, every line in the diagram becomes one line in the text.
Yes. Exactly.
Okay. And then what is the syntax for the spacing? Because you have some spaces here, you have some spaces in between here.
Mm-hmm.
What is the convention there?
Yeah, there I just wanted to have indentation that matched the punctuation. So if you actually hit the looking glass, the icon for viewing the and then just hit the button so that you see the text visualization of it. Because you hit the down arrow next to it to select which type of visualizer. If you hover over it again and just hit the icon itself, that's a button that opens up a visualizer.
Which one?
So hover over descriptive string.
No.
Just the on line 23. Excuse me. Sorry. The variable name descriptive string.
Wait.
Yeah.
Close this one. Yeah.
Oh, okay.
Okay. And here we can.
Okay. The thing that was going wrong for me is I didn't see that it was already open. Yeah. So apparently it's not part of the same window. Anyway. Yeah. So all I'm showing you there is that when you look at it that way, you see that supplier starts at the left, and now the two lines inside of the braces are indented. Excuse me. So that's the only thing I was trying to do with the spacing is just to show indentation.
In fact, you're always adding 4 spaces here, or it depends on the settings.
Yeah, I'm always just doing it as 4 spaces.
Okay, so in that case, it should become here 4, like that. No, did I do 1, 2, 3, 4? Yeah. So like this, it should be okay. Just continue. Where is my test window gone?
If you hit continue, it might. Oh, sorry. Let me close the door.
Already.
That should help a little bit.
here my test explorer. Oh, jumps out. Why is he?
There we go. Now I can see it. Yeah, so yeah, I think it's because you're in debug mode that it's still running the test and you're on the breakpoint.
Yeah, it's wait. Let's stop him, and now just run that single test here. Run it and see what it does. And now the window is so small. No, it does fail.
But now I'll bet it's failing on the next assertion on line 30.
Oh yeah, I haven't. Wait. This one again. Yeah, that's the one.
Yep.
Like
So
this, then put breakpoint here. Close this one. Now just have me this one. Let's go and see what the string is there.
and in fact the test failure message shows you what the string is, so you can do all of this without going into the debugger, which is kind of nice, I think.
That would be that's a good idea. Wait, add it to the watch, this one. Okay, so this is a very, very short string.
Right, yes. Yeah, and you still have the opening quote.
There is one,
Yeah.
one escaped. One escaped quote. Yeah.
Yeah, there you go.
So, and so we started here from the supplier. So we have. And what is that F then?
So that F represents field, and that is actually how the JavaScript version implements types. Is that it really just constrains the search based on a field. That was one of the early decisions that I made in the JavaScript version that has kind of hung on for a while. That at first type was not a special thing. So it was just any fact that has a field with this name and that value matches. And then it was just kind of by convention that the field name was always type. And it eventually got to the point where it became required that it be type, and so it's really just kind of an artifact of that earlier decision. So that's why I dropped that artifact in the new descriptive string syntax.
Here the S is still successor.
Yes, exactly. Yeah, so I kept that.
So we find all the successors from that supplier where the field is of type worker.
Yes. So that short descriptive string, that really is only that one little subset that's on line 25, at the end of the line. So s.supplier DWS worker. So that's what that simplified into. The old descriptive string could only describe one chain of steps. So the steps were follow your successors. So here follow the edges marked supplier in the successor direction and give me all the facts. And then F was now filter based on a field. F really stood for field, not for filter. For the field where the name is type and the value is DWS worker. And so it filtered those down.
Okay.
And so that that short descriptive string there could start from any fact and follow those steps and then give you back a set. So this this descriptive string doesn't capture the type that it's expecting to start from, and it doesn't have any kind of naming, any labeling happening inside of the pipeline, which means that you can't have pipelines that branch, because you need labels in order to reuse parts of the pipeline and define branches.
Okay. And why not just use these descriptive strings in every language?
That is the goal.
I mean, under the hood, they will be used. They will be used, but you make each time, in this case, a kind of link language.
Mm-hmm.
Is it really gonna be easier? Is it gonna be more familiar?
It's just an interim step, so that I can have the new version of pipelines in Janaga.net work with the old version of pipelines that's still in Janaga.js. So that's just an interim step until I can update Janaga.js to support the new syntax.
Oh, no, what I mean is, now from .NET, we are gonna follow. In fact, the user is only gonna see this. He's gonna create this type of queries.
Right. Yes.
He will never write a query like this.
That's correct. Yes.
But why not let the user write a query like this? Because what is a little bit annoying here are the spaces. But we might come up with something to make that easier.
Mm-hmm.
Because this is really a direct translation from the diagram to the string.
Mm-hmm. Yeah. So the so the goal for the end user is that they just be able to work within their language and they not have to use this syntax. This syntax is it's a description of the pipeline. It's a description of how to walk the graph. Versus the link above it is more of a description of the problem. What are you trying to end up with? And so the act of compilation is convert the problem description into a solution description.
More declarative way.
Yeah. Yeah. So so that also takes advantage of the type system. So it's verifying that all of the parts fit together. But one way that I think maybe what you have highlighted might be something that the end user sees is if they are using a different language that I don't have a client library written for. So if they are writing a Ruby application and they want to participate in an immutable substrate. So they might have Janaga running as a sidecar, and then they would be responsible for creating this text and sending it to the sidecar in order for it to execute the query. So that I might get there. I'm not 100% sure that that's going to be something that people are going to want to do. But at the very least, when the client and the server are talking to each other, they have to exchange pipelines, and this syntax will be the way that they do that from now on.
Yeah. Okay. Is this already documented, that syntax, or not at all?
No, it's not. No,
Okay.
it basically just evolved from the tests, um,
Mhm.
and so I
It might still evolve
yeah it's going to evolve further.
as we get into problems. Okay,
Yes,
so
indeed.
this video is the only documentation about.
So far, yes. Since the other one
I'm gonna
was
save
lost.
that. I'm gonna save that one. Can we try to do the next one together?
Yeah, let's do it.
And if that one is okay, then the rest I have to do myself. So here we had here we specified from suppliers. So I had a successor. What if we do the other way around? We search for the predecessor.
Mm-hmm.
Yeah. So then we do first it's fact. Otherwise it's not gonna test.
Mm-hmm.
Public void can specify just the inverse then, supplier from starting from worker like this.
Mm-hmm.
Okay. Then we come up with a specification. We put in it's just the inverse. We start from a worker, we get out a supplier.
Mm-hmm.
Specification equal to given in this case a worker. I want to match and then we go from here like this. I have what here? I started from a worker and I have all these suppliers there. Let me. And then here, there we started from supplier. I got worker. So from supplier, in fact, that's with a capital of type. I look for suppliers. That's with a capital here. So my supplier was on I'm starting from my worker. I'm going back to my supplier. So I look for suppliers where there is a worker that points to the supplier.
Right.
So where I have cannot be
Yeah, something that helps is the where clause will usually start with the same variable that you just declared. So it's usually a supplier dot something or a supplier equals something.
Yeah, but the supplier it's the worker that points to the supplier and not. Yeah. So wait, if I supplier equal to worker dot supplier, but is that gonna work?
Almost. So you've got a single equal, which means assignment. So yeah.
So here I select my supplier. Be that simple?
It might be. Let's try it.
Be for my pipeline. Is equal to the specification dot compile. Get the strings out of it. I could just copy this one and that one. Then we can see them string. By copying here.
Yeah. Would you like to guess what the string was going to end up being, or do you just want to run it and copy them?
That's a good idea. That's a good idea. So wait. So here we have the new one. I'll make it too difficult. Let's start from from that one.
Yeah.
So we started here from a worker. Yeah. So this becomes a worker from type DWS worker. And then I need suppliers. So I need a supplier. Was it with, yeah, that's with double P in English.
Yes.
And finally, I will select my suppliers here. Supplier is of type like this. And then supplier, I took successor in the supplier role, and it must be a worker. Now I'm looking for workers, but I'm looking for a predecessor in the role predecessor in the role supplier. And they have to be of type supplier. Is that correct?
It looks pretty good. Only one way to find out, though.
Let's try the old one as well then. Still a little bit cheating. I started starting from, but I have to try it 10 times before I can do it. Yeah, this was just that one. So predecessor in the role supplier, and we look for fields of type predecessor, and we look for suppliers. Big capital in that case. Save it. That's this one. Why is it not?
Oh, you're still in debug mode.
No, I don't need to put just run it and see whether it passes or not. Be an optimist. Was too optimistic.
Well, if I'm right, you're extremely close, and there's only one character off.
Let's
so
see.
let's click on the.
We'll find it.
Okay, you can also click on the failed test, and you'll see the output just below it, and it will show you the difference. So, yep, one character difference.
Right. This is the old one, so we are looking here then.
Yeah, so you can see in the message.
Supplier f.type.
Yeah, so you said I expect to get p.supplier f type space equal, and it actually found p.supplier f.type equal with no space.
Okay, it had to be like this.
Yep.
Okay. That's breakpoints, and run this one again. And now it passes.
Yep. Yeah, you did all of the right inferences there.
Yeah, but I had a good example. I think the other ones I can. I have just to try it on my own. Unless I get stuck again, but the syntax, is there any other syntax here? This is just also F, this is P, F.
Yes, you'll get into N and E for not exist and
E from,
exist.
okay. So actually it's literally a translation from the old queries.
Yes. Yeah, so yeah, not exists and exists are present in the old queries as well. and in fact, yeah, they fall down to a syntax very similar to the old queries, because it doesn't make any sense to do a projection inside of an exists or not exists. You're just going to follow one line to see if you get a fact out of the end or you don't.
Yeah. Then I will gonna try all the other specifications here that you made, translate them into my model, and then perhaps come up with some. Actually, for example, I had my user could have a name. The name is immutable.
Mm-hmm.
How do you? Because that's also a query for the mutable.
Right. Yes. Yeah. So that would turn into that you're looking for a name in facts of type username, and it's going to be, first of all, where the name user is equal to the user that you've got coming in, but then also
without successors.
Yeah, that's the next part, where also, so you'll have a second where clause, similar to what we see here, line 150 is a second where clause. So where not facts of type username, where username prior includes the username .any, A-N-Y. So that's a lot of syntax to say, but and in fact, that is not one of the shapes that I got to in this testing.
There we went
There
again.
we are. Yeah.
Yeah, we lost the screen now.
Yeah. So that's
I think one.
I think what you'll find is that's not a shape that that I've tested yet, having multiple successors. So so there you will run into a test that doesn't yet compile. So that'll be our first example of how we
Okay.
can expand the compiler.
Okay, that will be a reason to go look into the compiler source.
Yeah. So you yeah, if you want to stick with the problem domain and just continue to look at it as an end user, then we can kind of collaborate on working on the compiler, and then while you continue a different area on the model. But if you really want to dive into expression trees and all sorts of crazy stuff, then
Well, I prefer to dive into it to understand it. I know it. It always make the project later and later, but on the other hand, the more you know about it, at a certain moment it helps to process faster and to solve the problems. I prefer to really understand the things and to dive into it than to just copy and paste like I just did and then continue without really understanding what is happening beneath it. So I prefer to spend some time to really understand. Okay.
Yeah, absolutely. Yeah, so by all means, I will support you there.
Okay. I think the rest I should do myself, unless you still have something that you can advise me.
Yeah, so a couple of small things. First of all, even though in all of these tests you see that I'm explicitly declaring the specification, you'll find that you can use var. I think I only use var at the very last. It's able to infer the types of the specification. So yeah, that one's for the string, but I think the very last test, the specification itself.
Specification.
Yeah, bookings to refund. That one I'm just using var rather than declaring the type of the specification. And the reason for that is that the projection that is inferred there is an anonymous type, so I wouldn't be able to say it. And that's because on line 259, I'm just doing select new. I'm not giving it a name. So so you'll so you might want to just go ahead and get in the habit of using var, not having to think about the specification type. But if you do want to consider what the specification type is, another tool that you could use is go ahead and declare it as var, and then right click and let the refactoring tool to give you the inferred type. But it is able to completely infer that type. Which anytime I'm creating a DSL, that's something I always want to do, is to make sure that type inference works, because it's really powerful and helpful. Lost you for a second. Okay, I think you're back.
The connection might not be very well here. We have my youngest son has 8 other kids which are visiting us.
Oh yes.
And they all have their iPhone, so it's like a really big family now on just an old internet connection. So that might interfere a little bit.
That's awesome. Cool. Well, I do
So-
have some progress to show as well.
Okay, right, then I will stop this screen sharing. How do I stop it? No. How to stop the screen sharing?
So you should have a screen share button.
Wait, yeah,
Yeah, it has an X
got
on
it.
it. Yep. Okay, cool.
Got it.
All right. So,
All right. Yeah, I see your screen.
okay, excellent. All right, I have to. Okay. All right. So now, in addition to compiling the pipeline, you can execute it. So I have here Janaga test.create. So that's very similar to the syntax that we have in JavaScript, where that creates an instance of Janaga. So there's J. Good old friendly J, it's back. And so now we can do await j.fact. And here I'm giving it just a whole nested fact. So starting with the airline, so my identifier is IA. Then I'm using that to create an airline day. So that that day is today for that particular airline. And then using all of that to create a flight. So a flight from that airline on that day called 4272. So IA-4272 for today is a specific flight. So take that fact and put that into J. So that is now stored in whatever J uses to store its facts. So in this case, since it's Janaga test, it's using an in-memory repository. So we've got our flight.
Yeah.
We've got our flight cancellation now. So I'm going to create a flight cancellation for that flight. And then I'm going to run this specification. So given a flight cancellation, give me the flight. Well, this is a pretty simple specification that's just getting the successor. So it's just getting the flight itself. But then when I run j.query, so I run that that specification starting from the cancellation, then what I get back is an array, because a specification will always give you back a collection. So j.query always gives you back a collection, but this one, this collection has a single fact in it, and that's equivalent to the flight. So as you can see here, if I run that test, that passes. So this represents a whole bunch of stuff happening behind the scenes, which is, a lot of it is pretty exciting.
So actually, Jinaga is running now from .NET.
Yep, in the barest minimal form possible, it is running.
Mm-hmm.
So j.fact, well, first of all, we'll do Janaga test create. So that's creating a new instance of Janaga using the memory store. And the memory store, I'll show you where that is over here. There's an assembly called janaga.unittest. And that is an assembly specifically for unit testing. And right now, memory store lives in Janaga unit test. Eventually, it might break out and be part of a different assembly, but for right now, I'm just seeing it as a unit testing tool. We'll have to see as we bring in Blazor and Xamarin to see if it makes sense to have the in-memory store on the client side. But I think we'll probably want to go ahead and skip that. But anyway, so you can see the in-memory store. It's got it implements this iStore. So the idea is that you've got other implementations of iStore that represent different storage mechanisms. and it just needs to have these three queries or these three methods for now. There are going to be a few more when we add digital signatures and that sort of thing, so you can sign those. But so yeah, you can save a list of facts, and you can query from a starting reference a list of paths. So this is part of the pipeline, the part that's executable. And then you can load a list of fact references to get back those facts. So you can imagine implementing these three methods in SQLite or Postgres or whatever else you need. SQL. I can imagine implementing this in SQL so that I can have an application that's running a SQL database and it's doing all of its Janaga work inside of a transaction with your SQL database, so that your application is consistent with the immutable part of it. So yeah, all that stuff.
So that interface only has three different methods. That's all.
Yep, just those three methods.
Okay, so that's
So implementing new storage mechanisms should be a pretty mechanical step from there. And in fact, I was looking at the JavaScript version when I wrote that interface, and the JavaScript version just has a couple of extra methods. Like I said, for digital signatures, primarily is what the extra stuff is for. So we won't go into too much detail about how this is all working, but the important thing is that it's using these three data structures in order to do the work. And these three data structures directly map to three tables that you're going to want to have in a persistent version. So facts by reference give you a quick way to look up a fact object based on a fact reference. So let's dive into what these are real quick. A fact reference is just a type and a hash.
Okay.
And then a fact is a fact reference, a list of fields, and a list of predecessors. So this isn't the actual C# object that you give it, but it's been turned into a record that can be persisted and sent over the wire. So fields, we just have name and value, and the values, these are some helper methods that'll give you back values of string, date, time, int, float, double, boolean, but they just map to three different base class or direct classes. Yep. So string values and date times are both represented as string. Int, float, and double are all represented as number, and bool is represented as boolean. So does that look familiar?
Okay. That comes from SQLite.
That comes from JavaScript. So those are the only primitive data types in JSON.
Yeah, it's true. Because in SQLite, they don't really have types. It goes completely automatic under the hood.
Yeah.
If I remember well, they are also limited to these three types, I think.
Yeah, so they probably took that limitation from JavaScript because of implementation details. So here I brought that limitation in because I want to be compatible with Janaga.js. So all Janaga clients will just have these three data types, and then they'll map them to the richer type system of wherever they happen to live.
For date time, what about international times? Time zones?
Yep. All date times are just converted into ISO 8601, and they're all at the
And there is an offset. Yeah.
yeah. So it's all at UTC. So that Z is literal, capital Z. And so all
Zulu time.
yeah, yep. So all date times get converted into UTC before they get persisted or shared with other nodes, and that's a convention that that I started in Janaga.js, and I'm still pretty happy with that one. So I want to continue that. If you need to represent something like something that's localized, like an event at a known location. So this is going to be an in-person event. It's going to be in this particular time zone, and it's some dates in the future that you're planning. So those kind of things, it doesn't make sense for you to use UTC for those. So in that case, inside of your model, you would want to serialize your date to a string and use that that representation in the model itself. So the use of date time within a model is typically used for timestamps of things that have happened in the past.
Okay.
And so that's why I'm
so if you
have
have
happy with the UTC one.
If you have an appointment with a customer next year, particular date at 10 o'clock in the morning, even if they would change the time zone system, if they would move to a different time zone, so to avoid that his appointment shifts in local time, you just save it as a string.
Right. Yeah, exactly.
Oh, okay.
Yep. And so that's the same design decision you would make in JavaScript, because in JavaScript, if you say stringify a JSON object that has date times, it's going to convert those into strings. JavaScript is not going to convert them to UTC. That's something that Janaga did before calling stringify. So that's what Janaga.js does. And so Janaga.net also does the same thing. So if it's a local or unknown datetime kind, then it converts it to UTC. It's really annoying that .NET datetime has 3 kinds, and the most common one that you'll get out of any of the APIs is unknown. So if you were to call to universal time on something that's unknown, it'll assume that it's local to start with. But if you call to local time, it'll assume that it's UTC to start with. It's really annoying. So it's like, okay, do this right away and get it out of the way. But that's...
I think with these types, we should be able to do most of the work. And if there is anything special, we can still convert it to a string.
Yeah. Yep. So within the store, you've got your storage of those facts. Oh, we didn't look at predecessor. Predecessor. This is one place where I know that I need to expand it a little bit. So that's just an abstract base class that could be predecessor single, or the other one is predecessor multiple. And so that maps to just having a single valued field versus having an array or a collection. So the same 2 things are possible in JavaScript, so this is also compatible. But predecessors are within a role, and then the value is a single reference or multiple references based on which Dirac class you use.
Okay.
So those are those would be, if this were a persistent store, those would be serialized and indexed by reference, so you could quickly get the facts by reference. Then there's also edges. So an edge is predecessor to successor along a certain role. So you can traverse that edge in either direction. So that's how you run your successor and your predecessor steps within your pipeline. And then ancestors. This is for a given fact reference. Give me all of the fact references, all of the the direct predecessors and their predecessors and so on. So this computes the transitive closure of a fact. So by having that in a table, we can quickly say, all right, when I need to load this fact into memory, what are all of the predecessors that I also need to grab? And you don't have to go through all these edges recursively in order to compute that. So that gets pre-computed.
Just a function that makes it more efficient.
Yes, exactly.
Okay.
So I wanted to go ahead and do that optimization right here in the memory store so that I could see what the database will end up looking like. And then it becomes a pretty direct query, or a pretty direct translation from this link syntax that's working over the fields in memory to SQL syntax that would work in SQLite or Postgres or T-SQL. Because I don't want this to take a dependency on Entity Framework. Entity Framework could actually do this direct translation. If you just said, okay, these are no longer immutable dictionaries, these are now DB sets. Entity Framework would produce the right SQL for you, but I don't want to take a dependency on Entity Framework. I don't want to lock you into a particular version.
I think it's better to keep it pure. At least one problem less.
Yep. Okay, so we've created a Janaga instance with a memory store. Then when we do j.fact, here we serialize the fact that's coming in. So here it's just of type T, and I call it prototype because this is the Gang of 4 prototype pattern, as in here's an object that represents the fact that I want you to create. So now actually create the real thing, and that's what fact serializer does. So it does a whole bunch of reflection stuff. So this T collector right here is just an internal object that it uses. Come on, you can do it. There it is. That it uses to serialize runtime facts and turn them into these fact records. So you can see it's doing a whole bunch of reflection in order to get the fields out of it, decide if those fields are, get the properties out of it, decide if those properties are fields or if they are predecessors, and then convert those into the fact records. So one prototype will give you an array of facts, fact records, and that's because it might be something like this. So I'm saying I want you to store the flight. So let's deserialize the flight. Well, in order to do that, I get the flight fact, but then I also get the airline day, and I also get the airline, and I've got all the predecessor relationships that link those together.
Yep.
So that serializes that into this this immutable list of facts, and then I save them to the store, and that gives me back the ones that were actually added, the facts that weren't there before. And that I'm not using yet, but that's going to come into play when we have the query inversion. So those are the ones that you'll run through the inverses in order to see what has been affected. So so if you have any watches that are running, then that's going to you run the inverses, see queries affected or the facts affected. Look for the watches for the affected queries, starting with those affected facts, and say, okay, this is what was added, this is what was removed from those projections, because of these facts being added. So all that is still to come. And then here we are getting the the last fact in that list, which because I know the serializer works in topological order, the last one was the actual prototype that it was trying to save. Everything that came before were predecessors of that prototype. So that's just based on knowledge of how I know this algorithm works. So I'm probably going to encapsulate that in a class so that that knowledge has a place to live. But right now it's just sticking out here where it's like, okay, take the last one, take the reference, and then I want to deserialize from that list of facts that you just serialized. So I want to make sure this round trips. So deserialize them back into a type T and return that. So yeah, this round tripping, this means that if you give me something in a local time zone, when you get it back, it's going to be converted to UTC. And if there's any additional information that kind of gets captured along the way, then what you get back is going to have that additional information. One piece of additional information that that we don't directly see yet, but eventually will be represented to the end user, is the hash, the identity of the fact. So if you were to just take this, there's no way that you could compute the canonical hash of that fact. But once you've run it through j.fact, now you could compute the hash of it. Which kind of gets me to the next... Yeah, what was that?
Yeah, he will... that hash, he will return that one automatically?
You won't return it automatically, but you'll be able to do something like this. J.hash of flight.
Okay.
So yeah, you can do that in Janaga.js right now. So I'll also have that capability in Janaga.net. And then that way you'll have a canonical identity of that fact. It's going to be the same identity no matter where you are. And that is going to be useful in a lot of algorithms.
Before, if you would do j.hash of the fact before it is stored, then you risk to get a different hash because the information is not cleaned up and organized the way it should be.
Yeah, and in fact, I think that the way that I'll end up making this work it would be very similar to Janaga.js, in which if you've done that before you've added it to the fact, so you haven't round tripped it, then it's just going to throw an exception. So in the process of serializing it, it's computing the hash, and then inside of j.fact in JavaScript, it's creating another data structure that is associating these fact instances with their hashes. And so j.hash is able to access that data structure in order to say, oh, that's a particular instance that I've returned. What was the hash that I associated with it? And it doesn't have to go through the computation again. A slow way to do it would be to just simply take this same algorithm, serialize it, give you back the hash, but just don't store it. And it would compute a consistent hash. It would just be a really slow way to do that. And given how frequently you use the hash as identity, I wanted to make sure that it used the one that was cached at the time that it round-tripped through the Janaga object.
Anyway, any incoming fact has to, the first thing we have to do is to store it.
Yeah.
So it doesn't make sense to do it in a different way.
Right, exactly. Yep, so that's what you would that's what you would want to do. So that that really gets to something else that's really quite exciting, I think. when we serialize the fact, so I'll go back into the collector, serialize. So here I'm creating a fact reference. So I'm computing the hash from the fields in the predecessors. So the reference is the type and then the hash, and the hash is only based on fields and predecessors. The hash doesn't actually include the type. And how it does that is it canonicalizes the fields and predecessors and then computes the SHA-512 of that canonical string. So that's really spitting out some JSON where it's no white space. The fields are in alphabetical order, so fields as a field name sorted before predecessors. And then within here, these are ordered by field name, and the predecessors are ordered by their role name, and they will, when I get to the multiple predecessors, they will further be sorted in order of their hash. So that gives you a canonical JSON representation of a fact that no matter how you've expressed that fact, no matter what order you put the fields in, no matter how you ordered those sets of predecessors, it's always going to compute to the same string, which means it always computes to the same hash. And the really cool thing is that's exactly the algorithm that's in Janaga.js. So the hashes you get out of Janaga.net are exactly the same as you get out of Janaga.js. And that is key to making the two work together.
Because otherwise it's not gonna work out.
Yeah, exactly.
Mm.
So that was a lot of fun to get that working. I actually even added some tests to Janaga.js in order to compute the hashes so that I could use them in tests here. So pop in the stack. Yeah, so we serialize, round trip, store it, all that stuff. And then j.query. So far, yeah, we just looked at given match. So we've got that syntax for getting a specification. So we just simply take that specification, give it to j.query. It does the compilation and gives you back the results. So it is going to actually right now it's serializing the starting fact in order to get its reference. When I get the data structure in there, it'll actually have this starting point and it'll check to see if it's in that data structure, and it'll get the hash more directly, the one that was already pre-computed. Because presumably all of the starting points for your queries are already in your data structure. So, or they're already in your store. So compile the specification to a pipeline and then compute. Okay, so first of all, do the query on the store. So from the initial tag, that's the first one that appears in the pipeline declaration. That's the name of your starting point, your parameter name, and then the list of paths. So that's all of the different named paths within the specification. So every time you've got a name equals
and lines.
Each line is a path. So it's going to run each of those paths from that starting reference, and then it's going to give you back a set of Cartesian products. So a product is simply a bunch of fact references by tag. So this a little bit hard to see without a more complicated example, but if you've got multiple tags multiple paths, then they're going to refer back to each other. And so it's like, okay, starting from here, I ran this part of the pipeline and I got this set of results. And so now that starting point for that path and this set, each become products. And so you run that Cartesian product and you get all of the sets that occur when you run that query. And once you've got those Cartesian products, then you can compute the projection of each of those products, and that gives you back a list of results. So the upside is, let's go ahead and comment that out so it's not distracting. So the upside is that we get back an immutable list of flights, because flight is the type of the projection here. So that's the specification that takes us from flight cancellation to flight. And so you run that and you get back a single flight that is equal to this one here that you used as a predecessor.
Yeah.
And it's using be equivalent to because that that exact object that you get inside of this collection is not going to be the same instance as this object. So first of all, you haven't round-tripped. Well, actually, yeah, this one you have round-tripped through the system. But then, secondly, this one was the result of that of running the pipeline, and so it's going to serialize or deserialize a new instance for you. Some systems like Entity Framework, for example, go through a lot of extra effort to try to make sure that they reuse instances of entities, and I've found that that's costly. That you have to have a pretty big set of these are all of the entities that I'm tracking right now. So yeah, you'll if you read about Entity Framework, you'll read about change tracking entities, and so every time it materializes some results, it has to check against all of its change tracking entities to see, am I already tracking this one? If so, let me go ahead and reuse that same instance. And it's I think a costly part of the algorithm. So here, I'm not going to make that promise to you. If it turns out that it'll help me to optimize things and give you back the same instance, I will, but I'm not going to promise to give you back the same instance. So that's why it's using be equivalent to instead of be.
Nice progress. It was something that compiled only, and now it really executes.
Yep. Yeah, but
perhaps not all the cases yet, but
yeah, exactly. So I only have this one test working, and only this one model. But yeah, already I can see different branches, different directions I want to take it from here. So we already talked about the query inversion algorithm. Definitely need to get that working. But then here, this also points the way to, okay, I could actually write a Postgres implementation. I could write a SQLite implementation of the store. And can start down that path. There's also something in here that is a little bit troublesome to me, and that is when we serialize from this prototype, it starts doing a whole bunch of reflection over that type. So every time you add a fact, it's going to reflect over that fact's class and all of the predecessor types as well, and it's just going to keep churning through that. One simple, maybe simple step, one possible step, we'll just say, is to cache the reflections of those various data types so that you only do it the first time you see it, and that way what you get out of it is now a function that if you were to pass a new runtime fact into it, it will just run the function and give you back a fact reference or a fact fact object, or a list of them, in fact. So that's one thing to do, but then another thing that might be even better is at the time that you set up your instance. So right here, where you do your janaga.create, you give it an assembly, and then it scans the assembly, finds all of the facts that have the fact type attribute, and it says, okay, that's one that I'm eventually going to want to serialize and deserialize. So let me go ahead and pre-compile those functions. And now it becomes something that's very predictable, just a startup cost of creating the Janaga instance. So
Don't have a lot of different fact types, so the cache should not be too big.
right, yeah, it should be pretty manageable. And
Yeah.
by pre-computing it, now it becomes an immutable cache, and you don't have to worry about concurrency and two threads that are serializing facts of the same type at the same time. You'll end up computing those functions both in both of those threads, and then just overriding one with the other when you get to putting them into the cache. Versus pre-computing, you know that you've only done that work once. So I kind of like the pre-computing idea. It does add a little bit of a burden to the application developer. So I don't know.
Why does it add a burden to the application developer?
Because you would have to do something like here. You might say type of flight dot assembly. So you would end up passing that assembly into create, so that it knows to scan that entire assembly to find all of the other types. So it's a little bit of a burden because you have to know all of the objects that you're, all of the fact types that you're going to be supporting in that particular run, which most of the time you do, but maybe you have a plugin system, maybe there's something dynamic going on, and now you have to have those plugins produce their assemblies as well, and then give them all to the create function at the same time. It means that you can no longer hot load an assembly and then have it work from that point forward. And hot reloading is an important part of the .NET MAUI experience. So this decision might affect hot reloading. So all of those conspire to make me think maybe caching is the way to go.
It's a better option.
Yeah.
Yeah.
I'd have to figure out a way to hook hot reloading, and when I notice that happens, flush the cache so that I can recompute those functions with if you've made any changes to those data types. So yeah, that's a body of work that needs to be done in order to work well within the ecosystem.
We can always start with one and change it if we get into trouble.
Yeah. Yeah. So it could be that there's it could even be that there's an option that hey, I recommend that you pass the assembly in here, but if you don't, I'm going to find new types on the fly and go ahead and compile them. So you have the option of optimizing it for your situation. But then if you take
Yeah.
that option and then you want to use hot reload, then do you have to undo that option in your own application? It's tricky.
And yeah, the disadvantage of caching, you risk to calculate some things 2 times or 3 times concurrently, but
Mm-hmm.
it should not be too often.
Right. Yeah, I don't think it'll be too often.
Because once you have cached it, you have cached it. So
Mm-hmm. Yep. And I think it would not be too expensive to put locks around that cache. So it's like, okay, I need the function to serialize this particular type. So lock, is it in there? It isn't. Let me go ahead and compute it, put it in there, and now unlock. And now you don't run the risk of recomputing, but now you are holding that lock open for the entire duration of doing the reflection to compute the function, which is basically your startup cost. But now you're just spreading that startup cost around among all of the threads that would be using it. But anyway, it's pretty nice to have these kinds of problems now. Do we actually have something that's working?
that means I can even during the tests really create the facts,
Mm-hmm.
test whether they are created, whether they are equal, and so on.
Yep.
It's not just the strings that I can test. I can test the whole fact and the content.
Yeah, exactly.
Okay. Great. Then actually, yeah, we might start implementing it in one of the databases, for example, SQLite,
Mm-hmm.
just to play with it, to learn it.
Yep.
Let me see how far I get with that.
Excellent.
Good.
All right. Yeah, we've
Made-
gone over
made
a
very
bit
nice
today,
progress.
but yeah, quite a lot of progress to cover.
Okay.
Yeah, and that's okay. I'm actually on vacation today. It's the Independence Day in the United States, and so we're
Yeah, it's the 4th of July.
Yep.
4th of July.
Yeah. So
Yeah. Okay.
yeah, I got the day off work, but I was like, you know what? I have time and lots of things to talk about. Let's do this.
Mm-hmm. Okay. Anyway, still enjoy the rest of your holiday then,
I certainly will.
and thanks for sharing all this and helping me out. So at least I can continue.
Awesome.
Good, Michael. Have a nice afternoon for you.
Indeed. Yeah, and good
Okay.
evening to you.
Okay. See you next Monday, I think.
Yes, indeed.
Okay.
Yeah. See you then.